Alright, today we're going to look how to analyze vertical asymptotes of rational functions. It's going to be so awesome, fun, and exciting. Make sure you drink a cup of coffee so you don't fall asleep during this video. Alright, but we got a whole bunch of notation here. We got as x, blah, 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 blah. We got to figure out what that means, so we're going to do that. So first thing you're going to do is you're going to type this into Desmos. I've already done it for you. Got a nice little rational function here. We got some asymptotes going along. So what we're going to do is you're going to take this function right here, and we're going to factor it. So here's what I want you to do. Check it out. All right. You're going to put a little line right there. Try to make your line nicer than mine. We're going to factor the numerator. The denominator is already factored. All right, just like that. Okay. Now, here's the question I'm going to ask you. I'm looking for two numbers. All right, two numbers that multiply together that equal a positive 35. But those same two numbers add together to equal negative 12. That's a negative 12 right there if you can't see it, negative 12. Anybody want to take a guess? I like it. Negative 5, negative 7. That's perfect. Negative 5, negative 7, negative 5, negative 7. All right, so both of those what? Add up to negative 12. They multiply together to equal positive 35. So I'm going to put x minus 7, x minus 5. These are the factors. Now, one thing you can tell automatically, there are no holes or removable discontinuities in this graph. Okay? What do you guys notice about this graph that looks a little bit different than your typical graphs? Do you guys see how this is kind of slanted right here? So there's what's called a slant asymptote. This has a slant asymptote. Now, let me tell you the rules for slant asymptotes. We'll go over this later on in the year, but there's rules for slant asymptotes. In order to have a slant asymptote, you see that degree right there? That's a 2. This degree is 1. It just has to be 1 degree higher. So look what happens. I'm going to change the problem. If that's a 3, then what power would this have to be? A 2. And then what's created? A slant asymptote in the graph. If this was a 4, what would this power have to be? 1 less. It's always 1 degree less. So now you have a slant asymptote. You don't have to know that for this problem. I just wanted to show it to you because I thought it was cool. And if you don't think it's cool, that's okay. You're just probably not cool either. All right. So we have a slant asymptote. Do we have a vertical asymptote? Yes, we have a vertical asymptote at x equals what number? X equals, no, 4. Because that's the number that you would have to plug in there to make it equal to a 0. Now, we do have a couple of zeros, though. Where are the zeros located? Somebody help me out with this factored form where I put divided. It was what? X minus 7. Then it was x minus 5, right? It's all over x minus 4. All right. Now, check this out. I'm going to change colors. Let's make it green since we're getting, go green, man. Now check out the red and the green. Red and the green. What does that tell us? These are, in fact, the same rational functions. Now, what does the numerator tell us about it? The numerator tells us we have what? Zeros. We have 2 zeros. Where are the zeros located? One at a 5, and what's the other one at? 7, because 7 minus 7 is 0, and 5 minus 5 is 0. So that's kind of what is that? This is a review of the last assignment. Like, what are the zeros? What's the vertical asymptote? Where is it located? Now, that's not what we're dealing with right now. What we're dealing with is this right here. So what I'd like you guys to do, I'm going to pause the video right now. I'd like you guys to make a sketch of this graph in your journal right now. Make a sketch. All right, so what we're going to be talking about today is analyzing. So if you would please, like in your journal, we're going to analyze. When you're spelling analyze, make sure you spell it quickly, otherwise it becomes awkward. All right, analyze. This is funny. Okay, we're going to analyze the function around the asymptote. I'm sorry, it's just funny. All right, so we're going to be looking at what happens as we go towards the asymptote. So if you would please, could you guys please follow the hand? All right, follow the hand. So this is what, everybody, this is what's called approaching from the right. So could you guys write on your graph, could you guys write approach from the right, because that's the right side of the asymptote. And over here, can you write on your graph, we are approaching, put approach from the left, because this is on the left of the asymptote. Now, remember, our asymptote is at x equals 4. That's where our asymptote is located. All right? So, what does it mean to approach? If I say x approaches 4, now right here, that arrow means approaches. So this means as x approaches 4, well, it depends on which side. If x approaches 4 from the left, what's happening if it's approaching 4 from the left? Well, from the left, what's happening? What is f of x approaching as we're going closer and closer from the left? Where is it heading? Where's this graph? It's going down. So as x approaches from the left, it's going to what's called what? Negative infinity. But we don't put the word left. We don't put the word left. We put a minus, a negative. So as x approaches 4, so what does that little minus mean? From what direction? From the left. What is f of x approaching? It's approaching negative infinity. So you would say like the limit of f of x is approaching negative infinity from the left side. So watch my hand. As I'm going to the left, what's happening to the graph? It's going where? Down forever. But as I am approaching from the right, if I say as x is approaching 4 from the right, but I'm actually not going to use the word right, I'm going to use a little positive symbol. And that little positive means from the right. What's the limit of f of x going to be getting close to? Where is that approaching? Positive infinity. Because from the right, look what's happening. As I'm coming from the right, see, as I'm coming from the right, going up, where is it going up? It's going up forever, so the limit is going to what's called positive infinity. So what I'm going to be looking for is I'm going to be looking for an answer that has, as x is approaching 4 from the left, I'm going to negative infinity, and as x is approaching the asymptote from the right, I'm going to positive infinity. And that's the answer that this is one of the answers, this is the other answer. So let's take a look at this now. Let's take a look at our answer choices, okay? So as x was coming to the left, from the left, where are we looking for? We're going to where? Negative infinity, right? So as x approaches 4 from the left, we're going to negative infinity. So far that one's good. But as it's coming from the right, we're going to, so that one's looking like it's going to be the answer. Before I select, let's look at the others. As x is coming from the left, here's another one goes to negative infinity. But does it go to negative infinity on the right-hand side? No. So I know it's not going to be that one. So here's what I'd like you guys to do. All right? I'm going to hit check. By the way, could you guys, right now, I'm going to pause. Could you guys just write each 4 answer choices down, and I'm going to make a quick sketch of what the graphs look like in each scenario. So if you guys write this, I'll sketch a quick little graph of what that answer looks like. If you guys, we already know what this one does. All right, so I will make a graph right now. So I'm going to pause the video, write this, and this down, and we'll make a sketch of what a graph would look like in that particular scenario. All right, so what I'm going to do now, all right, is I'm going to make some sketches. We're going to call this answer choice A, answer choice B, answer choice D, answer choice C. All I'm going to do is make some quick little graphs, okay? So I'm just going to make a little x-axis, y-axis for each of these, all right? And I'll move it over here. And for my room, that's what I'm kind of doing. There's A, B, C, and then I'll just kind of go down and do the last one, which is D. you don't have to do this. You can put your graphs down right next to each other if you want. I'm just doing for this purpose. Now, everybody, do you see how all our asymptotes out of 4? So what I'm going to do for each of these is I'm just going to build an asymptote right here. I'm just going to call this the asymptote for each one. So I'm just going to draw the asymptote for each one. All right, so we're just saying the asymptotes at a 4. And then what I'm going to do in red is I'm going to draw what the graph would look like if it was that scenario close to the asymptote. All right, so it says as x approaches 4 from the left, f of x approaches positive infinity. So you'd have a graph that looks like this. Okay, and then it says as x approaches 4 from the right, f of x also approaches infinity. So you have another graph. They're both going what? They're both going up. So that's what answer choice A, this is a graph that answer choice A would look like. Okay? We already know what B is, right? As x approaches 4 from the left, it goes to negative infinity. So our graph, it could look like this, and the other one looks like this. So there's answer choice B. As x approaches 4 from the left, f of x approaches positive infinity. So this graph over here on this side is going to go up. And as x approaches 4 from the right, f of x goes to negative infinity. This graph's going to go down towards the asymptote. All right? And then you can probably kind of figure out what the last one's going to do. If both of these are opening up, what's both of these going to be happening? They're going to both open down. So you're going to have a graph that kind of looks where the arrows are both going down. So just the main thing, the one thing I want you guys to understand before I stop this video is you're looking at the graph near what? What's happening around the asymptote, not the end behavior, okay? So this is not dealing with the end behavior, it's dealing around specifically what's happening around the asymptote. Is it going up towards the asymptote or down towards the asymptote? And that's what it's about. I hope this video was helpful as you learn to analyze around the asymptote. Have a good day.